Okay, so in this video we're going to be looking at determining the rule for a graph based on the information in the graph or based on information given about the graph, whether it's a picture or whether it's a description, some points, some information. So we want to look at coming up with the equation given the new graph shapes we've introduced. So the first example here, we clearly have a hyperbola, and the most useful information to us immediately are the two asymptotes. Okay, so the vertical asymptote at x equals -1 implies that we've got a translation to the left by 1, so we need our equation to represent that. And the horizontal asymptote at y equals -2 suggests that we've got a translation down by 2. So we need our equation to reflect that. Then we've got a point here, and that point's about telling us about the dilation of this graph. Okay, so there are infinitely many graphs that have asymptotes here. Okay, it could be further away from these asymptotes and therefore have a greater dilation. It could be closer into these asymptotes and still have the same asymptotes. So we must think about the dilation. It could also be over here, and it would have the same asymptotes. So clearly we can see that we're expecting our dilation factor here to be positive. There isn't a reflection in the x-axis. Okay, so if we start with our most general kind of form then, so for our hyperbola, we want to be thinking about possible dilation factor. We've got x plus 1 for the translation left 1 and -2 for the translation down by 2. Then we're going to use our point to find the value of a. Okay, so we know when x equals -2, y equals -5. Okay, so we put that information into our equation. So -5 equals a over -2 plus 1 minus 2. Let's add that 2 over to onto both sides. So -5 plus 2 is -3. Now the denominator of that fraction, -2 plus 1 is -1. And so multiplying both sides by -1, a is equal to 3. And so therefore the equation of this particular hyperbola is 3 over x plus 1 minus 2. Okay, now I have to apologise. In the second example, I had copied and pasted the previous example and it has the same graph in it. This was the graph that the example is meant to have. So if you want to pause and take a moment to change the graph in your notes, for those of you that don't have notes in front of you, you are none the wiser to the fact that what I'm doing here doesn't match those notes. Okay, so again we want to find the equation, a possible equation for the graph pictured. So this seems to be a truncus. Again, our asymptotes are going to be helpful here. So our asymptotes, x equals +3, as the vertical asymptote tells us that we've got a translation to the right by 3. So our graph has translated across to the right by 3. Our horizontal asymptote at y equals 1 tells us that we have a translation up by 1. So we need our equation to reflect that. We've then also got a point, which again is going to enable us to think about any dilation factor. So we've got a truncus. Don't know about the dilation factor yet, we'll work that out. We know that it's gone to the right by 3, so it's going to be x minus 3 all squared because it's the truncus shape, and then up 1. Okay, so then we need to think about using this point to find the value of a. Now we can see that a clearly is going to be something negative here. This is clearly an upside down truncus. My strong advice is not to start by writing negative a up here. You'll confuse yourself, you'll work out a and then it'll be positive and then you'll write a positive number and you'll get yourself muddled up. Just call it a and know that you expect, in this instance, a is going to turn out to be a negative number. Okay, so let's sub our point in. So the point is 1/1/2, okay, or 1.5. So that is when y equals 1/2, x equals 1. Okay, so maybe let's take away 1, so that's -1/2. And then we've got a over 1 minus 3 is -2 squared. So we've got -1/2 equals a over 4. Multiplying both sides by 4, a is going to be -4/2, and so that's -2. And so therefore our equation, -2 over x minus 3 squared plus 1. Okay, number 3. The graph pictured has a rule of this form, y equals a times h minus x plus k. Alright, this is a little bit tricky in here. This is a bit non-traditional in terms of the way we've talked about the transformation so far. If we think about factoring out that negative, that's negative x minus h. Okay, and so the negative in here is your reflection in the y-axis. So we can see that that's already factored in to the general equation of the form of this particular graph that we've been given. And then we've got that plus k on the end. So we've got dilation factor, some sort of translation to the left or right, and some sort of translation up or down. This point's our most helpful thing here. This is telling us that we have got a translation left 3 and down 2. Sorry, not left. What am I doing? Right 3 and down 2. And then we've also got a reflection in the x-axis, but as I said, our general form already has that. But you might prefer to start from scratch here. It's up to you. Sorry, reflection in the y-axis. Bit out of it today, aren't I? And then this point is going to enable us to think about finding A, that dilation factor. Okay, so it's really important that we think about this negative x minus h here, plus k. Okay, so in this case we've gone to the right by 3, so our equation is negative x minus 3. Okay, that's factoring out that negative is allowing us to correctly read that reflection and that translation to the right in the right order, and then we've got down by 2, so it'll be minus 2 outside here. So now to write it back in that form it was in, if we multiply that negative in, this is the same as the square root of 3 minus x, and then minus 2. Okay, so now let's use the point negative 1, 6 to find the value of a. So y equals 6 when a is equal to negative 1. So I might add 2, so it's going to be 8 over here. And then we've got square root of 3 minus 1, so it's 3 plus 1, so square root of 4. So 8 equals 2a, and so a equals 4. So it makes sense that a is positive. Okay, we haven't got a reflection in the x-axis, we've only got that reflection in the y-axis, which is already in our equation. So therefore, this equation is going to be 4 times 3 minus x minus 2. Technically, in terms of finding the rule for this graph, it would be perfectly fine to leave it as square root of negative x minus 3, so factoring out that negative underneath the square root, but given it's sort of given us a general form, we should match our equation to that general form. Okay, the truncus with equation y equals a over x squared plus k, so no translation left or right, just a translation up or down, dilation from the x-axis, and possibly a reflection from the x-axis, in the x-axis, sorry. It passes through the points negative 2, 5 and 1, 11. Find the values of a and k. Okay, so we've got 2 unknowns and 2 points. And so using those 2 points, we're going to be able to form 2 equations with 2 unknowns that we can then solve to find a and k. Okay, so subbing in the point negative 2, 5, we put that into our equation. Y equals 5 when x equals negative 2. Okay, so that's 5 equals a over 4 plus k. If we multiply everything by 4 here, we're going to get 20 equals a plus 4k. Let's call that equation 1. Putting our other point in, 1, 11. Y is 11 when x is 1. Alright, so 1 squared is just 1, so 11 equals a plus k. So there's equation 2. Alright, then we want to solve these simultaneously. Now we could rearrange and use substitution, but these are beautifully set up for elimination. If we subtract them, the a's will cancel out. So I'm going to do equation 1 minus equation 2. So that's going to mean 20 minus 11 on the left-hand side, so that's 9. A minus a, it eliminates, that's the point. 4k minus k is 3k. And so k equals 3. I often find students have a real tendency to want to do substitution all the time. Elimination is so efficient if the things are set up nicely. Okay, immediately subtracting those 2 equations, we pretty much straight away find that k is 3. Okay. Alright, so then we sub k equals 3 back into either equation. You can choose. I'm going to go into equation 2. So I've got 11 equals a plus 3, and so a is going to be 8. Now, making sure we answer the question. So does the question ask me for the rule, or does the question ask me for A and K? In this case, it asks me for A and K. So let's be clear about our answer. Therefore, A equals 8 and K equals 3. Alright, example 5. Find the equation of the circle whose centre is at the point with coordinates 3, -2, and which passes through the point 1, 2. Okay, let's draw ourselves a rough sketch here to see what we've got going on. So 3, -2 and 1, 2. Alright, so 1, 2, 3, 1, 2. So 3, -2, there's my centre. And we go through the point 1, 2. So 1, 2. So we also go through that point there. So that means that the distance between these 2 points is the radius, okay? Because that's the centre at 3, -2. Oops, sorry, -2. And then if this is a point on the circumference, the distance between the centre of a circle and any point on the circumference is the radius. So then we can sort of, get an idea of what's going on with our circle. So we know that to come up with the equation of the circle, we need centre and radius. So we need to focus on finding the radius, and therefore we need distance between 2 points. Now, if you remember your distance between 2 points formula, that's great. If not, I've just drawn a beautiful diagram with a right-angled triangle here, remembering that the distance between 2 points is just Pythagoras' theorem. So the horizontal distance of the base of this triangle, x coordinates go from 1 up to 3, so that's 2. And then the y coordinates go from -2 up to 2, so that's 4. Okay, so we know using that little triangle that r squared is 2 squared plus 4 squared. So r squared is 4 plus 16, r squared is 20, r is square root of 20, which will simplify to 2 root 5. Okay, so we've got the radius. In fact, probably leaving it as root 20 is probably easier in this instance if we think about our equation of a circle. So the equation of a circle is x minus h all squared plus y minus k all squared equals r squared, where hk is the centre. So in this instance, we've got x minus 3 all squared plus y minus 2, so y plus 2 all squared equals the radius squared, which actually we have back here, radius squared is 20. And so there's the equation of that particular circle. The other way that you can do it, rather than using Pythagoras to find the radius, is you could simply start with the fact that your equation is x minus 3 all squared, y plus 2 all squared equals r squared, and then substitute in the point 1, 2. Okay, you could sub in the point 1, 2 and use that to find r. So when x is 1, y is 2, and that's just the distance between 2 points formula. Okay, so you're going to get -2 squared, which is 4, plus 4 squared, which is 16, is r squared, and so r squared is 20. So you could do it that way, and then obviously put the 20 back into your equation and give your equation. Okay, so either find the radius first, then you can pretty much write down the equation, or put what you know into the equation and then use your point in the equation to find that unknown value. Find the equation of a circle whose centre is at the point 5, -1 and which touches the y-axis. Okay, so again, let's draw ourselves a bit of a sketch so we can think about what's happening here. So 5, -1. Alright, let's say 5, -1 sort of over here. Now, if it touches the y-axis, so that means that this point here must be on the y-axis. Okay, so then we get our circle happening this way. So that means that's the radius of the circle. And we know what that value is, because that's 5, that's the x-coordinate. So the radius is 5 and the centre is 5, -1, so we've straight away got the information we need for the equation. So x minus 5 all squared plus y minus -1, so plus 1 all squared equals 5 squared, which is 25. Don't be afraid to draw a sketch so you can see what's happening. It's the quickest way to solve this question. Okay, so questions from exercise 4E. You can do all of the questions in that exercise today.